my lovely viewers. Thank you for joining me. Welcome to TJ's Maths and Further Maths Adventures. Still on bearings and distance. In today's presentation, we're looking at example 3. In my previous video, we have looked at the concept of bearing, the relationship between compass bearing and three-digit bearing, as well as keys to bearings, to finding bearings and distance. Let's look at how we can handle this question before us. The question reads, Y is 60 kilometers away from Z on a bearing of 135 degrees. Z is 80 kilometers away from X on a bearing of 225 degrees. We are asked to find the distance of Z from Y, that's question A. B, find the bearing of Z from Y to the nearest degree. If you look at it, all the bearing, this 135 and 225 degree are at X, because bearing of X from Y, the bearing of Y from X is 135 and bearing of Z from X is 225. So X will be the reference point. Let's look at how we can interpret this. Very important. To do that, let's sketch or do the interpretation here. Let's write down the solution and see how we can interpret this question. Let's draw our cardinal point here in the middle, and this is the North Pole. Of course, here will be X. First, Y is 60 kilometers away from X. From X means the bearing of Y will be at this X here, at this point. Very important. Okay? 135 will be here. So we have something like this. Let me stop here. Let it be as short as possible so that we can have more space. Then anywhere you stop like this is now 60 kilometers. And we have to be realistic in our length. 80 kilometers has to be longer than 60 kilometers in real life situation. And even on this presentation or interpretation, we have to be realistic. It means this 80 has to be longer than this 60. So we draw uh, another cardinal point here, very important. Okay, and this is Y. This is now Y. Very important. Then let's make progress. Z is 80 kilometers away from X on a bearing of 225 degree. 225 will fall here. It will be somewhere here, and it has to be longer than this. So let's draw another cardinal point here, like this. This will now be Y. This will not, sorry, this will not be Z. This will not be Z. Z is 225 from X. First, this is 135. That's the first bearing. Then the next one will be 225. Very important. So this is the interpretation of the question. The next thing to do is how we can connect. Let me take this Z up so that we can see. Let me write the Z here. Very important. The next thing to do is how we can connect this bearing together. Very important. You realize that if you are to start up from this point, meaning you end up below the other line of that cardinal point. Very important. Students tend to make mistake at this point. So care must be taken when you are to connect the points to form a triangle. Care must be taken. Okay, very important. Let's look at how we can connect these 2 points together. Okay. To connect this point now, we look at what we can do. Let's look at it. As I said, if I were to start up here, we'll end up down here. So let me connect this point together. It will be something like this. Let me draw it well. it will be something like this. Very important. So this is how to connect, meaning you start up, we end up below the other line. Very important. So this is how it will be, and here will be our 80 kilometers. As I said, we have to be realistic. I mean, this 80 kilometer has to be longer than 60 kilometer. So this will be the interpretation. The next thing to do, we have to find the resulting angles here now. And let's observe this very well, please. Uh, from this point to this point is 180. If I have removed 135, 180 minus 135 will be 45. So this angle here is 45 degree. Very important. Okay. Next, up to this point is 180. So if I remove 180 from this 225, I will find this other angle here. 225 minus 180, of course, I'll get 45 as well. So here will be 45 degree. You realize that if we add 45 plus 45, we have 90 degree. So this will be right angled triangle. Very important. Right angled triangle. And when the resulting triangle is a right angled triangle, to find distance, we can either use cosine rule because we have the two side and the included angle is given here. We can either use cosine rule to find the distance because we are asked to find the distance of z from y, which is this point. So we can either use cosine rule or we use Pythagoras rule. It will still give us the same result. Very important. But before I continue, you realize that this angle here will be 45 to Z shape. Alternate angles are equal. So here will be 45 degree as well. Because if here is 45, this angle here too will be 45 degree. Very important. Okay, but let's look at how we can find the distance now. We are asked to find the distance of Z from Y, which is this length now. Let me clean the question. Then the other question is the bearing of Z from Y to the nearest degree. So we can remove the question to solve for the distance of Z from Y. Okay, let's look at how we can do that. As I said, we can either use Pythagoras rule. I would love to use Pythagoras rule instead of cosine rule because cosine rule is more tedious compared to Pythagoras rule. Pythagoras rule states that in a right angle triangle, the square of the longest side, which is this hypotenuse, this is the hypotenuse because 90 degrees is facing this. This is the hypotenuse. Let's say here is theta. Okay. This theta now, this is the opposite, and this is the adjacent. This is the hypotenuse. 90 degree will always face the hypotenuse. Okay. So hypotenuse square now, that will be x square will be equals to 80 square plus 60 square. I'm using Pythagoras rule now. That's using Pythagoras rule now. Using Pythagoras rule. Okay. This will be x squared will now be 80 square will be 6,400 plus 60 square will be 3,006. X square now will be, we add this which is 10,000. To find x now, we take the square root of both sides. Square root of 10,000 will be 100. So this will be 100. So it means the distance of Z from Y is nothing but 100 kilometers. So this will be the solution to A. Very important. This is the solution to A. The B parts, we are asked to find the bearing of Z from Y. The bearing of Z from Y means we go to Y and start from the North Pole and keep moving in clockwise direction until we hit that line that is connecting X, Y, and Z. Then we stop. So this is the North Pole of Y. We keep moving and we hit this line that is joining them with Z. Then we stop. Whatever this angle is will be the bearing of Z from Y. Very important. And to do that, there are many ways we can approach this. Okay? If I can find this theta, since I know this angle as 45, whatever this theta is plus 45, remove it from 360 because angle around this point is 360 degree. So if I can remove this 45 from that 360, remove the whatever the value of theta from 360 will be the bearing of z from y. Very important. So let's do that. But to do that, we have to find theta. And to find theta, we have to use what we call SOHCAHTOA. SOHCAHTOA. In this SOHCAHTOA, is it sine we are going to use? Is it cosine or tan? Let's look at it. We have the opposite and adjacent. Opposite, adjacent. Okay, it means we have to use tan. So this will be tan theta now. Will be opposite. Opposite here is 80 because this theta is facing the sideline that is corresponding to this 80. So it will be 80 divided by 60. And we can reduce this. Very important. So theta now will be the tan inverse of 8 divided by 6. What will be the tan inverse of 8 divided by 6? Let me remove this A since we are through so that we can have space up. I don't want to touch the drawing. Very important. Okay. So theta now will be, let's use our calculator. Ensure that your calculator is in degree, please. Very important. We'll press shift, then we'll press shift, then tan inverse of 8 divided by 6. We'll have 53. Let's divide 8 by 6 first. 1.333. Then shift tan inverse of 1.333. What are we going to have? We'll have 53.1294 degree. So this will be this angle theta here. As I said, to find the bearing of z now from y is nothing but 45 plus theta. Remove it from 360 because angle around this point is 360 degree. So we can say that the bearing of z from y will be 360 degree minus whatever the value of, we add this theta, which is 53.1290 degree plus 45. Let's add plus 45, or let me write it here, 53.1294 degree plus 45 degrees. What are we going to have finally? What are we going to have? Minus it from 360, we'll have 261.8706 degree. But the question said to the nearest degree. To the nearest degree means to the nearest whole number. Very important. And to the nearest whole number, after this decimal, we'll look at the next digit. This is a round up number. From 5, 6, 7, 8, 9 are all round up number. So we have to round this 8 as 1. So we round it up, meaning as 1. We add 1 to this 1 now. It will be 2, 6, 1 plus 1 is 2. So it will be 262 degree to the nearest degree. To the nearest what? Degree. So this will be the bearing of z from y. Very important. Thank you for watching. Please do share this to your learned colleagues. And don't forget to subscribe to TJ's Maths and Further Maths Adventures. You can follow me on TikTok, Instagram, and Facebook. In my next video, God's willing, we'll look at as many questions as we can from this bearing and distance. It's a very wide topic in mathematics. Thank you for watching. See you in my next video.